Hi everyone. In this lesson we're going to find the measures of angles when chords or secants intersect inside a circle. The theorem says the following: if two secants or chords intersect in the interior of a circle, then the measure of the angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So the key point over here is that these chords or secants are going to be intersecting inside the circle in the interior, and it could be two chords. The only way that chords could intersect would be in the interior of the circle, or it could be a secant and a chord, or two secants, as long as they are intersecting inside the circle. So I'm going to draw here, and I'm going to use one chord and one secant. So that will be chord and a secant. Could be that way. And I'm going to name this the point of intersection. I'm going to name this A, B, C, D. And I'm going to name also the point of intersection inside the circle, which I'm going to call E. So what does the theorem say? It says that the measure of the angle, we're actually talking about this angle or that angle. Since they are the same measure because they are vertical, we are referring to it as the angle, but it could be any of them. So the measure of the angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So let's say we're talking about this angle here. So the measure of this angle, which is the same as the other one, is going to be 1/2 the sum of the arcs that are intercepted by this angle, which is this arc AC, and the other arc that is intercepted by the vertical angle to this one, which in this case would be arc BD. So I'm going to highlight these arcs, those two. So the measure of this angle would be 1/2 the sum of these two arcs. So the same thing happens with the other angle BED, since it's vertical to the other one. So I'm writing what the theorem says. It says that the measure of angle AEC is 1/2 the sum of the two arcs, arc AC, 1/2 the measure of arc AC plus the measure of arc BD. So you add these measures and take half of that, or divide by 2, which is the same as 1/2. And with that, I'm going to do 3 examples, and I would leave 3 exercises for you. The instructions says find each measure. So in this case, we're finding the measure of angle 1, which is this angle here, and that is formed by these two secants that are intersecting inside the circle. So the measure of this angle should be half of these two arcs. The measure of angle 1 would be half of these two arcs, which are 40, half of the sum of these two arcs, which are 40 and 52. So measure of angle 1 is equal to 1/2 40 plus 52. 40 plus 52 is 92, and then 1/2 of 92, which is the same as dividing by 2. 92 divided by 2 is 46 degrees. So that's the measure of angle 1, and of course of the angle that is vertical to angle 1. In number 2, we don't have to find the measure of the angle, but we have to find the measure of arc GH. So we need to find the measure of this arc. But the idea is the same as long as we use the equation, the original equation, which is that the measure of one of the angles is equal to the sum of half of the sum of the two arcs. You could use that same equation either to find the measure of the angle or to find one of the arcs. As long as you have the other two pieces, you should be able to find the third one. So in this case, we have two things. We have the measure of arc FE, and we have the measure of this angle. This angle is 45 degrees, and we're looking for this arc. So this angle, which is 45 degrees, should come, so the 45 degrees should come from half of the measure of arc FE added to the measure of arc GH. And we know the measure of arc FE, that's 28, so I can substitute that. So 45 is equal to 1/2 28 plus the measure of arc GH, or if you prefer, you could use a variable. You can put a variable and then use the variable here. So now we have this equation which needs to be solved, and we have to remember that multiplying by 1/2 is the same as dividing by 2. So basically I could rewrite this, the right side, as a division instead of writing multiplication by 1/2. I could actually write as division by 2. So these two would go to the other side by multiplying, because right now it's dividing. So that would make 90 is equal to 28 plus the measure of arc GH. And so now I have only one step to do in order to solve for the measure of the arc that we want to find, which is to subtract 28. The measure of arc GH would be 90 minus 28, which is 62 degrees. And we're done with number 2. And finally, number 3, which is to find the measure of angle 5. Angle 5 is this one here. Notice that angle 5 is not one of those angles for whom we have the measure of the arcs. So we have these two arcs, which are not related to angle number 5, but we could find, for example, this angle or the other angle, which is equal to this one. And then we would use linear pairs to find the measure of angle 5. So what I'm going to do is I'm going to name this angle here, angle 4. So I'm going to find the measure of angle 4 using the intercepted arcs, and then use linear pairs to find the measure of angle 5. So the arcs that are intercepted by the angle 4 and its vertical angle are those. So the measure of angle 4 would be equal to 1/2 the sum of 90 plus 130 and 90 plus 130 is 220, and taking half of 220, the measure of angle 4 would be 110 degrees. So now I know that this angle here is 110, therefore the measure of angle 5 should be 180 minus 110, which is equal to 70 degrees. And we're done with number 3. And that's how we find the measure of angles that are formed when chords or secants intersect inside the circle. But we could also find the measure of the arc given the other two pieces of information. I'm going to leave for you the 3 exercises here. Practice with them, and don't forget to do your homework.